Hi everyone, how are you? Okay dears, this is RANA sir. Welcome to our RANA sir educational channel. Today I will talk on a topic whose name is motion in a plane, but in this topic I will explain about the concept of circular motion, and also I will explain the parameters which are used in the circular motion. So all concept I will explain here in detail. Therefore you concentrate on this live video from starting to end to understand its general concept, that is its geometrical meaning. Okay, now you also share this live video with your college friend and students so that they can also update their knowledge on this point, and also simultaneously you subscribe this educational channel more and more for getting such types of knowledge. And also I am going to give you one suggestion point, that is you follow it positively. First of all, you take one notebook and one pen, and then you sit at your location properly, positively, safely. So each and every concept you have to note down on your notebook, which are written on the blackboard, and also those data which are spoken by me. So positively you listen it, and also you write those information on your notebook. Okay, so here I will explain with you, that is this is the class 11 physics, that is available in both medium, that is in Hindi medium and also in English medium. Now it is based on NCERT pattern, so I will explain its concept in detail, because no term will be repeated in this pattern. Okay, now here motion in a plane, that is also called in Hindi समतल में गति. Now in this chapter I will explain the concept of circular motion, that is वृत्तीय गति. I will say that this is the वृत्तीय गति. So what is the concept of वृत्तीय गति? That is the concept of circular motion. I will explain its definition and then I will translate its meaning in Hindi, so students who are reading in Hindi medium, those students can understand its concept easily. Okay, now here I will say, if any particle which is moving on the periphery of the circle, it means that particle will have a fixed point, and that particle will also have a fixed length. So such type of motion is called the circular or uniform circular motion. Okay, so in this case its definition I will explain, and after explaining each concept I will define clearly. Okay, in Hindi, so students who are reading in Hindi medium, those students can understand its concept easily. Now this is the circular motion, in other words, that is written in Hindi, वृत्तीय गति. Now what is the concept of circular motion? Already I have explained with you. Here I am drawing a circle. Now I am drawing a circle, and center will be a fixed point. I am going to say 2. Now this is also called periphery of the circle. Periphery of a circle, या circumference of a circle. CIRCU CIRCUN circumference, FERENCE circumference of a circle, CIRCLE. Here I will say CIRCLE, and its center I will say that its center is O, but its radius I am considering R. So if any object which is available at the point P, and this object is moving on the periphery of the circle or circumference of the circle, that object has a fixed point. That fixed point here I am saying origin. Origin means its coordinate will be 0 and 0, but from this point to the periphery of a circle, this will be a fixed distance. That fixed distance I have to say r. So this length is r and this length will be also r. Here I will say if I will take any point here, so that will be also r. And in this time, in this side I will take, so all length will be r. All length will be r. So I will say such type of movement, of a particle is known as circular motion, or in other words we can say that is वृत्तीय गति. Okay, so if any particle which is moving on the periphery of the circle या circumference of the circle, but that particle has a fixed point, that fixed point is for the center of the circle, and there will be a fixed distance. That fixed distance I will say the radius of the circle. So this is the concept of a particle which is moving on the periphery of a circle. Such movement I will say that is the uniform circular motion. Okay student, I hope that you are understanding this concept easily. So I will define this concept in English, and after explaining it I will also explain this concept in Hindi, so student who are reading in Hindi medium, those students can understand easily. Okay, now here I will say in Hindi, because here I have to take 1.4. in other words we can say that एक ऐसा पार्टिकल, एक ऐसा कण जो सर्कल के परिधि पर मूव करता है, सर्कल के परिधि पर मूव करता है, लेकिन वो पॉइंट जो होता है एक फिक्स बिंदु रखता है. उस फिक्स बिंदु से जो होता है उसका जो डिस्टेंस होता है, दूरी जो होता है कांस्टेंट होता है. दैट कांस्टेंट मीन्स नियत रहता है. तो इस तरह का मूवमेंट को जो होता है एक समान वृत्तीय गति करते हैं. इस तरह के मूवमेंट को एक समान वृत्तीय गति करते हैं, या इन अदर वर्ड्स दैट इज इन इंग्लिश दैट इज नोन एज यूनिफॉर्म सर्कुलर मोशन करते हैं. आई होप दैट यू आर अंडरस्टैंडिंग वेरी इजीली, बिकॉज if a particle which is available at a center periphery a circumference of a circle and that moving in a path, but that point has, or that particle has a fixed point, and here I have written that is the O. This fixed point to the periphery या circumference of the circle, I will say that is a distance, and that distance is a fixed distance. So that fixed distance I will say the radius of the circle, and such type of movement I will say the uniform circular motion. Okay students, so all the information I will write in a word, so each and every student who are reading in CBSE board, those students can understand easily its meaning. Okay students, so now I am going to explain it. Okay, the definition. So first of all I will write a definition of circular motion. When a particle which is moving with a uniform velocity या moving on the periphery or circumference of a circle and that particle has a fixed point. That fixed point is called that fixed point is called center of the circle. Center of the circle and center of the circle and that has fixed distance. Fixed distance is known as radius of the circle. Radius of the circle. Such type of movement is called circular motion. Such type of movement is called circular motion. I will say CM. That is the circular motion. Okay. So I hope that this definition you are understanding very easy way, because here I have taken one circle and that circle has a fixed point and any particle which is available on the periphery of the circle and that is moving. So in this case, from that particle to the fixed distance, that particle to the fixed point, I have a distance and that distance is called the radius of the circle, and such type of movement is called uniform circular motion of the particle of the body or any object. Okay, so this is the required concept, required meaning of the circular motion. Okay, that is dictated. Now this information I will also explain in Hindi, so student who are reading in Hindi medium, those student can understand its definition easily. Now here यहाँ पर हम कहेंगे कि एक वृत्त है, उस वृत्त के परिधि पर कोई भी ऑब्जेक्ट रखा गया है, कोई भी वस्तु रखा गया है, वो वस्तु जो होता है मूव करता है उस सर्किल के परिधि पर, लेकिन उस सर्किल के परिधि पर जो ऑब्जेक्ट है, जो वस्तु है, वह एक फिक्स पॉइंट के अकॉर्डिंग जो होता है मूव कर रहा है। जो फिक्स पॉइंट है, उस फिक्स पॉइंट के नियम के अनुसार जो होता है वो ऑब्जेक्ट जो होता है उस सर्किल के परिधि पर मूव कर रहा है। उस फिक्स पॉइंट को हम यहाँ पर कहे हैं कि वो सर्किल का सेंटर है। सर्किल का सेंटर को हिंदी में केंद्र कहते हैं। वो सर्किल का केंद्र होता है। उस सर्किल के केंद्र से जहाँ पर ऑब्जेक्ट परिधि पर रखा गया वहाँ से जो डिस्टेंस निकालते हैं, वो डिस्टेंस जो होता है सर्किल के हर परिधि के हर बिंदु पर वो डिस्टेंस जो होता है कांस्टेंट होता है, जिसकी वजह से हम कहते हैं कि वो लेंथ को जो होता है हम उस सर्किल का रेडियस कहेंगे। रेडियस क्या हिंदी होता है त्रिज्या, उस सर्किल का वो त्रिज्या हुआ। इस तरह से जो भी ऑब्जेक्ट होता है, जो भी वस्तु होता है सर्किल के परिधि पर मूव करता है, उस तरह के मूवमेंट को हम वृत्तीय गति करते हैं या सर्कुलर मूवमेंट करते हैं या सर्कुलर मोशन करते हैं। अब नेक्स्ट these are the information and you are understanding very easy way. Okay, now next topic we have to also explain about the parameter of the circular motion. So next parameter I will also explain about the radiator and then angular displacement, and then I will explain about the concept of angular velocity, and after explaining all the information I will also explain the relation between angular velocity and linear velocity. So these are the expressions are important because if we will understand, so with the help of these parameters we will solve any question which will be based on circular motion. Okay student, so you take its positive because all parameter I will define one by one and you have to understand clearly. If you will get any problem या any issue या any query related to circular motion, so you try in the comment section positively, and then I will see your comment positively. I will resolve, yeah, I will provide the appropriate solution of your question. Okay student, so you follow it positively. Now further I will erase this one, and after erasing this one I will explain the parameter of the circular motion. Okay, so now first of all I will erase this topic and also its concept, and then I will start to explain the parameter of the circular motion. Okay students, if you are understanding all the information to this, will you like this live video, and also you share this live video with your friends and students so that they can also update their knowledge on this topic. So here I have to explain parameter of the circular motion. Parameters of the circular motion. Circular motion. Okay. So this topic I have to explain. Now here first of all I will explain about the radial vector. So first parameter I will define radial vector. Radial vector. Three surface. That is written in three surface. This is the concept of three surface. Now in this case I will say I have to draw a circle. Now here I will say this is the origin of the circle. Now I will say this is the radius of this point P, and I will draw here. I will draw here one point. I will say this is the A. Now at t is equal to 0, at t is equal to 0, when time I will take in t is equal to 0, and when that particle is going to move along this direction, so time t is equal to t. In this case I will say this radial vector, this radial vector at three surface, that is represented with like this. So I will say any particle which is leaving at the point P and that is moving at t is equal to 0, that is starting from t is equal to 0, it means that time is equal to 0 second. So t is equal to 0, this t is equal to 0 second, and here t is equal to 3 second. So after moving, it is coming at the point A. So its time is taken by the object, या particle is t. So here I will say the length OP, which is equal to R, and this is also known as radial vector. RADIAL vector. Okay. So this is the required way. So this is the point, and this point is known as the center of the circle, and it is moving periphery of the circle. So from this point to this point I will say R, from this point to this point I will say R, from this point to any point on the periphery of the circle, या periphery circumference of the circle, I will say R. So all distance will be same. In this case I will say that will be the radius of the circle. So OP, here I have written here OP is equal to, this is also it is like this, OP is equal to vector R, and this is also known as radial vector. Okay student, so this is the concept of radial vector, that is radial vector is also represented with R. Okay student, I hope that you are understanding very well. So this information I will also explain in Hindi, so student who are reading in Hindi medium, those student can understand Hindi. इसमें कहा क्या है, एक सर्किल लेंगे, एक ब्रेक लेंगे, उस ब्रेक के केंद्र को हम O मानेंगे, और उस ओ से जो होता है सर्कल के करीब एक पॉइंट पी लेंगे और ओ से जब पी को मिलाएंगे तो वह एक डिस्टेंस मिलेगा। वह डिस्टेंस जो होता है वह डिस्टेंस जो होता है आर होगा, लेकिन इसकी डायरेक्शन जो होता है सेंटर ओ से जो होता है इसके डायरेक्शन परिध पर सर्कल के परिध पर किसी पॉइंट पर टेंड करेगा, उसको हम वेक्टर आर से रिप्रेजेंट करेंगे। इसलिए इस लेंथ को या इस डिस्प्लेसमेंट को हम कहेंगे या रेडियल वेक्टर के नाम से हम रिप्रेजेंट करेंगे। इसको रेडियल वेक्टर कहेंगे। या रेडियल वेक्टर का जो मैग्नीट्यूड लेंगे या ओपी डिस्टेंस होगा ओ से ए। सो इफ एनी पॉइंट if I will take on the periphery as circumference of the circle from the center of the periphery of the circle, I will say that is the length r, and that is also known as the radial vector. Okay student, I hope that you are understanding this parameter, that is the radial vector easily. Now after it I will explain angular displacement. What is the concept of angular displacement? I will explain. So in this topic I will erase, and after erasing second parameter I will add here. Second parameter of the circular motion is angular velocity, angular displacement. Angular angular displacement, and it is also written in Hindi, that is कोणीय विस्थापन। कोणीय विस्थापन This is the कोणीय विस्थापन. Angular velocity, angular displacement means that is the कोणीय विस्थापन. Suppose that here I will take a circle. Here I will take a circle. I will take a circle and its center is O. So I will take the radial vector R. That is here I will take a P. Now another point I have to take here A. So I will say this is the angle between A, O, P, O, A. That is theta 1. Here I have to consider theta 1. Similarly, I will take another angle, that is theta 2. This is the theta 2. Now this angle will be how much? From this point I will say this is the theta 2. This is theta 1 and this is theta 2. Total angle is theta 2. So here I will say this angle will be theta 2 minus theta 1. Okay, theta 2 minus theta 1. Now here I will say this point is B. This point is B. Now from here I will draw a line. I will extend a line and then I will get this is the segment. This is a segment, that is A, O, B. This is also a segment. This is segment, and A, P, and B. According to this way, I will say that is the major segment. But here I will say this is the R. A to B, that is the R. So R length we have to obtain. So angular velocity is written delta theta, which is equal to theta 2 minus theta 1. Theta 2 minus theta 1, that is delta theta. Theta 2 minus theta 1, that is delta theta. And I will say if this is the displacement, so I will say this will be displacement in x. Delta s divided by radius. That is radius. This is the radius. Then OR is the radius R. So angular displacement is written with delta theta, which is equal to theta 2 minus theta 1. This is available in the angle, but I have to put in this part. This is the value of delta s, and this is the value of delta r. This is the radius and this is the angular that is the linear displacement. So I will say, so this is the angular displacement is equal to linear displacement divided by radius. In other words, I can say that here angular displacement, angular this angular displacement which is equal to, I will write linear displacement divided by radius. Linear displacement divided by radius. So this is the required formula. So this formula we have to remember. Okay. So delta theta which is equal to delta S divided by R. Okay, student. So you have to remember it. Delta theta which is equal to delta S divided by R. This is the angular displacement. Angular displacement each and every students are knowing. That is theta, and theta which is equal to theta 2 minus theta 1, and that is written in the form of R. R A to B is the R, and that R is here delta S divided by, this is the radius. Okay. So angular displacement, definition of angular displacement, we can say that if any particle which is available at point P, after some time that is moving at point O, so I have got the angle of inclination, that is the minor sector which is theta. Now from point A to B it is going, so I am getting a angle theta 2, that is from OB, that is theta 2. So we have to get the angle AOB, that is theta 2 minus theta 1, that is the angular displacement, and that angular displacement I have written here delta theta which is equal to theta 2 minus theta 1, and it is written as delta S divided by R. Okay. So angular velocity in the language I have to written as angular displacement which is equal to linear displacement. This is the linear displacement because S is the linear displacement. So delta S is equal to change in linear displacement divided by radius. Okay. So I have to remember this formula for making the relationship, relation between angular displacement, angular velocity, and also angular linear displacement. So we have to write relationship also for solving numerical which are based on circular motion. Okay, students, I hope that you are understanding very well. So I will explain all the information in Hindi, so students who are reading in Hindi medium, those students can understand easily. Okay. Now here यहाँ पर मैंने कहा है कि एक सर्किल लिया है, उस सर्किल के सेंटर से मैं इस सर्किल के परिध पर जो है एक पॉइंट पी लिया हूँ, और वो से जो तक पी तक हम मिलाया हूँ, उस डिस्टेंस को हमने कॉल करा है। जब कोई भी ऑब्जेक्ट जो होता है पॉइंट पी पे, ऑब्जेक्ट का मीनिंग होता है बस, जब कोई भी बस जो होता है पॉइंट पी पे जब पी से जो होता है पॉइंट आर ए पर जाता है, तो उस केस में जो कोणीय जो विस्थापन होता है, वो कोणीय विस्थापन यहाँ पर थीटा हुआ, लेकिन जब ए से जो बी पर मूव करता है, तो उस केस में जो होता है जो एंगुलर डिस्प्लेसमेंट होता है थीटा 2 होता है। इसलिए हम चेंज इन एंगुलर डिस्प्लेसमेंट निकालेंगे तो वो थीटा 2 माइनस थीटा 1 होगा। तो थीटा 2 माइनस थीटा 1 को हम ऐसे डेल्टा थीटा कहेंगे, और इसको चाप बटे त्रिज्या के नाम से हम इसको लिख देंगे। इसको हम चाप बटे त्रिज्या के एक यहाँ पर एंगल के रूप में दिया गया है, यहाँ पर जो का डिस्टेंस के रूप में दिया गया है डेल्टा एस डिवाइडेड बाई डेल्टा आर। ये जो होता है एंगुलर या कोणीय विस्थापन होता है। कोणीय विस्थापन के लिए फार्मूला होता है डेल्टा थीटा विच इज इक्वल टू डेल्टा एस डिवाइडेड बाई आर। और डेल्टा एस, अगर डेल्टा एस और आर में अगर कोई भी अननोन पैरामीटर्स है, तो अगर थीटा 1 थीटा 2 दिया गया है, तो हम डेल्टा थीटा इज इक्वल टू थीटा 2 माइनस थीटा 1 से हम उस वैल्यू को हम इवेल्युएट कर सकते हैं। ओके, सो दिस इज द इंफॉर्मेशन available in the symbol form. ये सिंबल फॉर्म में इंफॉर्मेशन अवेलेबल। अब हम इसको जो है अगर लैंग्वेज के रूप में लिखना चाहते हैं तो डेल्टा थीटा को हम कोणीय विस्थापन के नाम से जानते हैं। एंगुलर डिस्प्लेसमेंट का मीनिंग होता है हिंदी में कोणीय विस्थापन। ये जो होता है चेंज इन लीनियर डिस्प्लेसमेंट होता है, जो रैखिक विस्थापन होता है, जो रैखिक विस्थापन होता है इसको हम रैखिक विस्थापन का चेंज इन लीनियर डिस्प्लेसमेंट हम पाएंगे। लीनियर डिस्प्लेसमेंट है, ये लीनियर डिस्प्लेसमेंट जो होता है यह रैखिक विस्थापन है, और आर जो होता है वह रेडियस होता है। वो रेडियस को हिंदी में हम त्रिज्या कह सकते हैं। इस तरीके से हम पाएंगे कोणीय विस्थापन जो होता है रैखिक विस्थापन बटे त्रिज्या होता है। इसको हम लैंग्वेज के फॉर्म में हम रिमेंबर कर सकते हैं, लेकिन इसके लिए डायग्राम यहाँ पे ओके स्टूडेंट। आई होप यू आर अंडरस्टैंडिंग ऑल दीज इंफॉर्मेशंस इजीली। ओके, सो you like this live video and also you share this live video with your colleagues, friends and students so that they can also update their knowledge on this topic. Okay, now you also subscribe this education channel more and more. Okay students, so this is the second parameters, that is the angular displacement. After it I will explain about the angular velocity. That is also important because some question can be asked on that topic. Okay, so you have to remember this one, delta theta which is equal to theta 2 minus theta 1 which is equal to delta s divided by r. Okay, now I will erase it and after erasing I will explain that point. That is angular velocity, velocity, angular velocity, that is written into the कोणीय वेग, कोणीय वेग, that is called कोणीय वेग, that is the angular velocity. In this case, I will say if any particle which is moving on the periphery or circumference of the circle, but that particle has the angular velocity, and angular velocity is represented with omega, and that omega value is coming delta theta divided by r. That is coming delta theta divided by r. So after simplifying, I will get a expression and then I will also write the relationship, here relation between angular velocity and also the concept of angular displacement. Okay, so all concept I will use one by one. So here I will draw a diagram that is related to angular velocity. So I will say this is the center and this center is unites A, that is O, and I will take a point which is available on the periphery of the circle, so that point I will say E. Now in this case I have to calculate angular velocity, so here I will say that angular velocity is represented with omega. Now here if any particle which is moving with angular velocity omega, so I will say that omega can be obtained by the symbol omega which is equal to delta theta divided by delta theta divided by delta t, because here I have to say if particle is moving t is equal to 0 second, t is equal to 0 second, but after time t it is coming with t second. Now we have to write angular velocity, that is represented with omega, and here omega I have to write. Now here I will say omega which is equal to, I will write here limit delta t tends to 0. So here I will write delta theta divided by delta t. When after simplification I will say this delta will change with this small d. Delta is also changing angle and delta is also available in change in time. So here I will write d theta divided by dt. So this is the expression. This is the expression for angular velocity. So angular velocity which is equal to d theta divided by dt. Okay, I hope that you are understanding this concept easily, because if any object which is moving with the angular velocity, so in this case I will say that angular velocity is divided by omega, and that omega has a value that is change in angular displacement divided by change in time. So displacement divided by time, that is known as velocity, but here if particle is moving in a circle, so in this case I will say that circle has a velocity angular, and that velocity, that angular velocity is represented by omega. Okay, so omega is equal to delta t tends to be 0, which is in the bracket I have written here delta theta divided by delta t, and after simplifying in the place of delta t, delta I know that that is the change in theta, and here change in time, and it is also represented with a small d, and in delta t also represented with a small delta t. So I can simplify. After simplifying I will write delta theta divided by delta t, that is the angular velocity. Okay, so I hope that you are understanding all these concepts easily. Okay, now this information I will also explain in Hindi, so student who are reading in Hindi medium, those student can understand this concept easily. Okay, ये यहाँ पर कहा गया है कि एक सर्किल है, इस सर्किल का केंद्र O है, इस केंद्र O से जो हम R डिस्टेंस पर एक पॉइंट सर्किल का है, उस पॉइंट को हमने P कहा है। जब पार्टिकल वहाँ से मूव करता है तो एंगुलर वेलोसिटी का अध्ययन किया, लेकिन जब स्टार्ट किया उस समय जो टाइम जो था 0 सेकेंड हुआ, लेकिन T समय पर हमने उसको एक एंगुलर वेलोसिटी अध्ययन किया, कोणीय वेग को प्राप्त किया। उस कोणीय वेग को जो ओमेगा से रिप्रेजेंट करते हैं, वो ओमेगा बराबर होता है डेल्टा थीटा बटे डेल्टा टी होता है। डेल्टा थीटा बटे डेल्टा टी। सपोज कीजिए कि यह ऑब्जेक्ट यहाँ पर मूव किया, इस ऑब्जेक्ट को यहाँ से यहाँ पर मूव किया, इस पॉइंट को ए कहेंगे, इस पॉइंट को बी कहेंगे, तो यहाँ पर यह यूनिट थीटा 1 है, यूनिट थीटा 2 है, यूनिट थीटा 2 है, तो डेल्टा थीटा जो होता है हम लिख सकते हैं थीटा 2 माइनस थीटा 1। फिर डेल्टा थीटा जो होता है, डेल्टा थीटा जो होता है थीटा 2 माइनस थीटा 1 है। इस तरीके से उसके कंसेप्ट को हम एक्सप्लेन कर सकते हैं वन बाय वन। ओके स्टूडेंट, नाउ दिस इज द कंसेप्ट ऑफ एंगुलर वेलोसिटी। तो यह एंगुलर वेलोसिटी का कंसेप्ट है। हम एंगुलर वेलोसिटी को हिंदी में कोणीय वेग के नाम से जानते हैं। कोणीय वेग को हम ओमेगा से रिप्रेजेंट करते हैं, कोणीय वेग को हम ओमेगा से रिप्रेजेंट करते हैं, और ओमेगा जो होता है डेल्टा थीटा होता है, डेल्टा टी होता है। अब हम इसको लिमिट वैल्यू लेंगे, लिमिट डेल्टा टी टाइम्स टू की इसका मतलब होता है एक क्षणिक एंगुलर वेलोसिटी वी हैव टू कैलकुलेट हियर। यहाँ पर जो क्षणिक वेलोसिटी को कैलकुलेट कर रहे हैं, एंगुलर वेलोसिटी को कैलकुलेट कर रहे हैं, यहाँ पर डेल्टा रिप्रेजेंट करता है वो थीटा में है। यहाँ पर यह डेल्टा रिप्रेजेंट करता है कि टाइम में चेंज होता है, इसलिए डेल्टा जो होता है डी से रिप्रेजेंट कर डेल्टा को चेंज करेंगे डी के फॉर्म में, इस डेल्टा को भी डी के फॉर्म में चेंज करेंगे, इसलिए डी थीटा बटे डी टी जो एंगुलर वेलोसिटी होता है। ओके स्टूडेंट, आई होप दैट यू आर अंडरस्टैंडिंग दिस concept easily. So you like this slide video, and also you share this slide video with your friends, colleagues and students, so that they can also update their knowledge on this topic, and also simultaneously you subscribe this educational channel more and more. Okay student, now after explaining this concept, I will explain next information, that is the relation between angular velocity and what is the relationship between angular velocity and linear velocity. So all information I will explain here. Okay, so now first of all I will erase this one, and after erasing this one I will keep the relationship between angular velocity and also linear velocity. Okay, so firstly I will erase it, and after erasing I will define the relationship between angular velocity linear velocity. So next information is the relation between angular velocity and linear velocity. So we have to define. Okay. So positively you will stay on this live video, and then I will explain each and every term in detail, so you will get its relation. So angular velocity, that is delta theta, which is written delta s divided by r. This is one relationship. Here I have to write. Now we have to write omega, which is equal to, we have to write d theta divided by dt. Okay, we have to write this information also. So I will simplify it. After simplify, I will not simplify here. I will simplify the equation number 2. This is the equation number 2. So we have to define. Also. I will simplify as I will divide. That is r is equal to, in other words we have to divide r, v equal to r into omega. We have to define this expression. Now omega is available, so I will divide first equation by second. So after dividing, I will say a term that will be as dr divided by dt, ds divided by dt, that is the velocity. Here I will say, when I will divide both equations from second equation to first equation, I will divide like this. Equation second is divided equation 2. So after dividing with omega delta theta, which is equal to, here I have to write except that is delta s divided by r. Now here will be delta theta and divided by delta theta. Here I will divide, so not I will divide the theta, I will multiply it here. So I will multiply equation 2. So here I will say delta theta into omega, which is equal to, here I have to write delta s divided by delta t into delta s divided by delta t. So here will be delta theta. Here d theta divided by r. I have to write here. So I will write here. So d theta and delta theta both have same meaning. So here I have to write it. So this term and this term will be cancelled out. So here I have to write r, which is equal to delta s divided by delta t into 1 divided by r. We can do it. So after simplifying, I will say delta s divided by delta t, which is known as velocity, that is the linear velocity. I will say that is the linear velocity. So here I will write omega, which is equal to v divided by r. After simplify, I will say v is equal to r into omega. So this expression, so evaluated expression, I have already explained, that is v is equal to r into omega. V is equal to R equal to omega, because in any object or any particle which is moving on the circumference of the circle, that is periphery of the circle. So I have got a relationship between small v, that is the linear velocity, and also angular velocity, and this is the radius of the circle. So V is equal to R into omega. This is the relationship between angular velocity and linear velocity. So this is the required way to prove V is equal to R into omega. So first of all, I will write the formula for the angular velocity, and also I will write the formula for the angular displacement and also angular velocity, and then I will multiply these two expressions, and after multiplying I will get a value that is a one relationship. That relationship is equal to R into omega, where V is the linear velocity and R is the radius of the circle and omega is the angular velocity of the circle. Okay, so this is the required concept. So this concept we have to know one by one. Okay, so if you will have any doubt here, any confusion, so you write all these information here or your doubt in the comment section. Possibly I will look, that is I will observe, and after observing I will give the appropriate solution of your question. Okay, student, if you are understanding this live video, so you like this live video and also you share this live video with your colleagues, friends and students, so that they can also update, that is improve their knowledge on this topic. We can also say that you also subscribe this educational channel more and more. Okay, now first further I will also solve some numericals which are based on this topic. Okay, so time is minimum, so I will explain some numerical on this topic next time. Okay, if student who are missing study class, so again you go in my video section and you go in my playlist section, where already I have uploaded study video, and you observe, because there I have used all concept of the kind of height of the projectile, and also how to calculate the horizontal range of the projectile, and how we have to calculate the magnitude of the angular magnitude of the velocity when that particle is moving along the y-axis and also along the x-axis. So we have already calculated the magnitude of the both component. Okay, so properly I have explained each and every question in detail in both medium, that is in Hindi medium and also in English medium. So which medium you need to prefer, so you watch there, and after watching and you write all information possibly you are when you are understanding possibly, so all those information write on your notebook for the revision, that will enhance your future. Okay, so all these informations are related to circular motion, which is available in the motion unit. Okay, so this is the required concept. Thank you for watching this live video. I will meet you on the same time, that is 30 minutes past 7 p.m. to 8 p.m. If you have any doubts, so you write your doubt in the comment section, yeah, query in the comment section. Possibly I will see, and then I will reply the solution of your comment in detail. Okay, thank you for watching. Jai Hind, Rana.